So hello everyone. I thought I'd give you just a little background as to who we are, where we fit in the University of Utah Health Sciences Center, to give you an idea of how we're setting up OpenSpecimen to support our research enterprise. So we're with the Biomedical Informatics Services Core within the Center for Clinical and Translational Science. Sorry. Just a quick overview of the core, the projects that the OpenSpecimen fits in within our core, and then I'll go over the infrastructure and implementation of our OpenSpecimen setup. So this is just a quick overview of where we sit within the Health Sciences Center. The Center for Clinical Translational Science is a CTSA award-funded center that supports the research enterprise across the institution. We have a few key projects that OpenSpecimen will be one of. So part of this is that our data services includes federation and translation, terminology management, data collection, exploration, analysis, and we also work within a high-performance computing HIPAA-compliant environment as well. So that builds up sort of a pipeline of applications and systems that work to support our researchers throughout their entire projects, whether that be just, pure cohort identification or trying to actually define data sets in translation using such things like OpenSpecimen for biospecimen data. So some of the specific ones that we're working on where OpenSpecimen fits in that, we're starting with a new next generation build of our data translation federation framework called OpenFurther, which will actually be in the end pulling data from OpenSpecimen along with patient-generated or captured data from REDCap for clinical trials, along with clinical information from our enterprise data warehouse. And we hope to manage most of that as a aggregation type platform where we actually can harmonize and then generate analytical data sets. So we have great interest in actually pulling data from in more near time from OpenSpecimen for people who are looking for whether it's just for folks that have available specimens that do have a clinical record or just available specimens of a certain type. So specific to OpenSpecimen, we have some implementation goals. One of them is that we would set this up in a multi-tenant environment. Most of our researchers operate sort of independently, and we're not going at this from a central biobanking point of view, although biobanking will be a functional part of this down the road. They also have mixed storage locations, so there are shared freezers that some centers or institutes within the Health Sciences Center run that PIs use. Our central processing lab within the CCTS is called the CTRC. They actually are sort of the functional driver of OpenSpecimen. So everyone who's going to be using OpenSpecimen in our setup will be working with the CTRC when they request specimens such as DNA samples derived from whole blood that's from a participant in one of their trials. Each one of the PI lab sites also autonomously operates most of their the implementation of their clinical trials. There is a central clinical trials management, but when they actually go out and implement that, that's mostly on their own. So with that in mind, we wanted to support all those workflows through the CTRC. So we're starting with everybody who is going to be using the CTRC for requesting derived samples or process samples. In the end, that also means we need to support distributed printing of labels. Right now, we're starting with centralized printing with the CTRC lab, but we'll be enabling remote or PI site printers to be part of this as well. So the implementation of the systems is pretty standard. We do have a training site where a server where the folks that are interested in using this set up an initial site, their users, the collection protocol, and their storage container, so they can kind of get a handle on how they're going to be arranging their workflows. From there, we actually start to validate those workflows with the sites, and then any changes that need to take place with the incoming or updates from Khashoggi for the newer versions of OpenSpecimen. I follow along on our development server because I can blow that away pretty quickly and rebuild. And then we can update test and production, which is actually in a protected space with the validated collection protocols and their workflows. We do have on the list to do to integrate REDCap with the collection protocols with the plugin that Stanford had shown on an earlier call. The print server also lives in the protected space, but it can also go out and send print jobs on the closed network to the PI site labs. So it's essentially we set up training for our sites to get our users familiar with it, start validating their processes, and then promote them to test and production from there. The reason why we have to do this is because every lab is essentially different. And here's sort of the way it lays out with the workflow. Each site, we have a requirements gathering sort of phase, and then we have some initial contact with them where we figure out exactly where it is that where they are in their specimen management, how they are intending to use the CTRC to process samples, and then from there we start to set up their collection protocols and other metadata about their site so they can configure their visits in OpenSpecimen. So that would be steps 2 with all the specimen requirements. From there, the processing workflow starts with the CTRC. So we essentially are relying on specimen carts within some of the newer functionality in OpenSpecimen to create the selection of samples that need to move from one site to the next or to be processed. And so those are just the temporary, lists of specimens. Once a specimen's been dropped off, they'll create a cart and then create a transfer event over to the CTRC where the lab personnel will process the samples. A separate protocol down the road will actually be set up to take an aliquot of certain samples that have been that are part of the CCTS biobank and flow through there. But right now, what's happening is that the specimens are processed, either derived or aliquoted, and then they're in a temporary storage location. They're marked, ready to be picked up essentially in the lab. And then the lab uses the shipping functionality, so that we create a shipping cart which notifies the lab that their specimens are ready. That goes out to the PI lab. So steps 1, 2, 3, and 4 are for anybody who's going to use the CTRC for specimen processing, whether or not they use OpenSpecimen in the end at their lab to manage their samples. We're hoping that this becomes a very useful setup for everybody and that they do want to move to using OpenSpecimen, but it's not a requirement for actually using the CTRC to manage their samples in the lab, but they will have to use OpenSpecimen to actually use the specimen processing. That's pretty minimal setup, and hopefully with folks that are using REDCap, that will be even more easy to populate up their participants in their protocols in a more automated method, so we can set up rapid transfers to the CTRC for processing. So step 5 at the lab, if they do want to manage their samples, then we actually have to go through a little bit more training with them to set up the process for managing their containers in their lab, how they're going to continue a standardized workflow so that their naming conventions are in line with the rest of how the CTRC works, so that they can have sort of a two-way workflow between them in the future, between either storing samples sometimes at the CTRC where they do have some freezers where they're it's a condo sort of environment, and then also at their own sites, so we can request processing at the CTRC from samples that they have in their sites easily with transfer events and shipping carts. So there's a lot of text on these slides. I'll just read through some of this stuff really quickly, but the workflow is basically broke down into a pre-CTRC process and a post. So prior to setting up samples in the CTRC for processing, the CCTS, BMIC, and the PI sites will help get them up to speed with them being the PI sites, with setting up their protocols, their participants, and some of the naming conventions for labels. So we have a standardized naming structure for our studies, which most folks and sites probably do as well. That kind of thing sets it up so we can actually easily identify samples as they move through all the workflow, whether they're samples that end up leaving the CTRC and are in the lab, or stay in one of the freezers in the CCRC. It's easy for us to track those down. And then we'll also start on the collection protocol. The CCTS is interested in helping folks use a more standardized ontology for using consent tiers. We'd like to be able to search through the OpenSpecimen system for specimens of a certain type that have a certain type of consent available. So we're exploring implementing a new our consent ontology. It's actually, I think it came out of originally Medical University of South Carolina for a research project management system. I believe they're not using that now, they're using Spark, but that ontology is useful to us as well. And I believe that was posted on a wiki page for a future feature request on the OpenSpecimen wiki. Once that happens, all the participants are registered. We can either do that with bulk load. Consent documents are either recorded in OpenSpecimen or in REDCap. So linkage with REDCap will make that easier as well. And then there's a few more pre-CTRC processes that need to take place. One is the collection events, the container types and the naming conventions, and then the collections of the samples. So there's all this stuff that sort of has to be set up. What we're trying to do is avoid the management of all this stuff being put onto the processing lab, and that's currently what's happening. They've got a couple of different samples, and they spend a lot of time helping people walk through the different applications they use to get samples ready to be dropped off. That causes a lot of different issues across the board, whether someone's actually having to enter in data that takes too long, or there's missing data, or they just put in placeholders when they really would rather not, that sort of stuff. So we'd like to standardize that so it happens before they actually even walk in the door. And that way the processing lab can just move on with their work and not have to deal with any data entry errors either. One thing about the conventions on the naming for storage locations is that because this is going to be a larger install for the Health Sciences Center, we'd like to have everyone in the system name their top-level containers, like freezers, fridges, that sort of thing, with a location code that the university uses for all of our rooms. So that location code can then be used in reports to essentially show the number of freezers we have across all the buildings. That's more of an administrative management report, but it also helps us with knowing, what freezers are in what place. Maybe there's a building that has power issues and things like that, and so folks can sort of plan for whether or not they can put more freezers in one building or not, that sort of thing. Of course, you can do that all manually now, and most labs just can tell you what they are, but it's easier to do it if we have a report. Okay, from there, we have the second part of the workflow, which really breaks up into two parts, which is processing of the CTRC. So the samples are entered. These are the parent samples, so let's say they're whole blood. And those are set up into a cart. The PI will then transfer them, and that transfer event's recorded. We can also use the shipping event to the CTRC. That happens fairly autonomously, so that the PI or the runner or the coordinator can drop off the samples. We'll have a print record from the export of just the CSV export of the transfer event or the shipping cart. We're working on some requirements on actually building a custom report that will print out essentially a batch of the samples that were dropped off with a either generating an ID or something like that that can then easily be scanned. Then you get a list of the samples that come up. Of course, that's a future thing we'd like to see happen. Right now, we're just going to have a CSV export. And then probably just build up a quick little report in Excel or something that generates a barcode there so that people can scan them in quickly when they pull them off the shelf to be processed. Then what the CTRC does is they want to be able to use label generation quickly. So they'll have the labels ready to go because they're already printed on the samples that were dropped off. And then they want to be able to print labels of the next derived type. And so pre-printing is very helpful in the newer versions of OpenSpecimen. They'll be able to actually say, I've got all these new vials that are going to be going into the DNA extraction machine. They label them quickly, and then they can actually pour in the blood for those, and off it goes. That happens relatively quickly once the samples are dropped off. So for a DNA-derived process, so they're looking for DNA, the CTRC runs this stuff through the DNA extraction machine. Then they need to actually use a couple of custom forms to capture the quality assessment after using a nano drop, or they'll have a gel run where they need to record the output of the gel. We're working on a method to actually either slice up the gel image or upload the whole gel to the excuse me, the sample. So it's essentially just a link for each sample that shows where that was run through a gel. So once that's all done, and whether or not the samples are of high quality or low quality, they'll record all of that, set them all up for a shipment event. So they'll select the samples with a cart, notify, so the shipping event will notify the PI that it's ready to go. It's placed into a temporary container. They come back, pick it up, and once that happens, the PI can then transfer that to a storage location in their lab, which would then set off that last earlier workflow step that I mentioned, step 5. Or it would just be that it was shipped. It's in a virtual location somewhere else, and it's gone because they're not using OpenSpecimen in their lab. Let's say it's they're using another commercial package. It's outside of the Health Sciences Center, or they're just another lab that wants to continue using their current process. So that's essentially the workflow. In order to do all this, we had to set up sort of a project management system, and this was a recent addition to our process that was implemented by a staff member who's had previous experience on this as a data architect. He's setting up and managing this process. It includes an onboarding training session, so we essentially mirrored what Kershagney does for folks when they want to set up OpenSpecimen. But because we have such a wild variety of folks who are going to be trying to do this, we need to meet with every lab to come up with their requirements. So we have a standardized workflow where it's an initial training session where we kind of meet with them, create a startup plan for the lab. We're using Jira and Confluence to manage that stuff. And then we have a set of 5 training sessions that are broken up into different steps. Find 5 main training sessions for the PI lab, most of which we use Pornima's expertise to help us walk through. We're hoping to get that built up into a sort of a self-sustaining process where we can have Kershagney jump in, get things kick-started, and we'll have enough material built up that we can work through each lab a little more quickly. Once that's happened, then we start to create we get them set up so they can actually do new samples coming in the door, and then we start working on as a secondary process, the inventory of their current specimen storage and a dependency plan for a transition workflow for their older samples that are already in their systems. So the project steps are essentially what I mentioned, the meeting session. We go through and get their collection protocol configuration done. The next one is a day-to-day operations sort of walkthrough of how things would work with OpenSpecimen. Then we do an end-to-end trial run with the CTRC, because this is all on the premise that they're using the CTRC. And then we work on the last part of it, which is their lab management and query and reporting. So the main data collection or data entry steps for this type of workflow kind of goes like this in an overall high-level view. The PI site works on collection of the samples and the dropping off to the CTRC. The CTRC transfers them to this temporary storage. Then they process the samples. They ship the process samples back, and then the PI site receives them and updates everything after that. And that's all. That's where the data entry is broken up. So we have to set up roles within OpenSpecimen to make sure we capture that same kind of workflow so that the right people can see the right data and it's segregated appropriately. So I blew through all that really quickly. I don't know if anybody has any questions before I kind of I'll go over the printing setup as well. Okay, so the printing is pretty straightforward. The difference here is that we've set it up to use a shared file watch folder and also with the database connection. There are some systems, because we're in this distributed sort of environment, where they need to make a connection to the database rather than and they can't connect to the file server. So you have nice label set up to watch the database table for the print job data and also for the file server. And the CTRC right now is set up as to be the main printing hub, where we have the folks coming to the lab. They print off like the preprint samples or preprint labels for their samples they'll be collecting, or print them there if they have to over-label them. Then the next step will be adding PI label printers as we go. So within the setup of the workflow, we have some pre-printing for different protocols where they have little kits set up. They're not quite sure, or they don't have a rigid schedule of when folks come in and they just want to have some kits ready to go. Then we have where you can the CTRC will be printing the expected DNA labels for the requested derived samples. And then they also can print aliquot labels at the CTRC, or once we have the label printing at the PI lab, they would be able to print aliquots that they do in their lab. That's essentially it. So that gives a high-level overview of what we're trying to do with OpenSpecimen and kind of what we're doing. The stage we're at right now is that we have one of our larger labs sort of on board. We're getting it set up so they can begin to process new samples the next few weeks. And then we have a lot of labs that have backlog that's ready to be put into OpenSpecimen for processing at the CTRC. Once we have that workflow moving as quickly as we can, then we'll start working with labs to build in their inventory of back samples that are in storage. So if anybody has any questions, I'll be happy to answer or anything else.
This is Sri here, Randy. You said in the next few weeks probably will go live with the first lab. How many protocols does the first lab user have, and how many users will be using the system?
So there aren't a whole lot of users. There's in this particular lab, there's only there's 6, 7 users, and there's 2 protocols, 1 main protocol. The reason why we're starting with this one is because it's the most complex. So it's not the number of samples, it's the number of users. It's that the setup is essentially like this. They're the Utah Children's Project, where it's essentially there was an offshoot of the children's the National Children's Project for following kids through development. And so they have a lot of samples, and they have a long time to track these kids. So we have 20 events over 20 years that they're capturing samples. Then they also have storage of samples in a secondary lab, where that lab will may also be using OpenSpecimen, but their freezers are owned by someone else. But the UCP, the Utah Children's Project, stores samples there. They use the CTRC to process samples and get them back, and the CTRC also stores some of their frozen cell line cell pellets in their freezers. So the workflow gets complex on managing the samples back and forth. That's why we started with them. After that,
Okay.
there'll be some other protocols that actually do have a higher volume where they have, this is research, so it's not clinical enterprise. We don't have thousands of samples coming in the door every day, but for per protocol, it's anywhere between 5 to 50 samples a week.
Okay. And as an extension to that, say in the next 6 months to 1 year, uh, what would be the scale of, say, number of users using the system?
Well,
Any
so
idea?
sure, each lab is, these are PI labs, so they're anywhere between 3 and 10 people. We've got at least another 20 protocols to go through. So we're probably upwards in the 200 users range at least, and then we'll probably end up with anywhere between 30 and 50 protocols, depending on how many we can get in the backlog done.
Great. And what are these guys using right now? So are they using primarily Excel sheet or
It's all over the map. So there are Excel spreadsheets. There's folks that are using commercial products. I think one of them had FreezerWorks. There's another one. There's another in-house system that's being used on campus from the Cancer Institute. So some folks will continue to use that. Some people are transitioning from that. They're and everything in between. I mean, people have little FileMaker databases or whatever else set up. So.
Got it. Yeah, that sounds pretty exciting. So we'll we'll keep tuned in to see how your progress goes.
Yep, progress is good. We hope to continue progressing.
Right.